This is one of the rare instances where they tried to use a spacesuit in a vacuum chamber, but quickly realized that it's impossible in a high vacuum, so they immediately started using swimming pools to train and remained silent on the absence of vacuum chamber training by astronauts, which basically is a lie by omission.
As I stumbled backwards, I could feel the saliva on my tongue starting to bubble just before I went unconscious. And that's kind of the last thing I remember.
Essentially, he had no pressure on the outside of his body, and that's a very unusual case to get, and there's very little in the medical literature as to what happens when you have that. There's a lot of conjecture, that your fluids will boil,
You can see a little bit of bubbles start going.
I could feel the saliva on my tongue starting to bubble.
They weren't able to construct proper spacesuits, and they didn't want their spacemen to get boiled, so they went to the swimming pool.
Here's where they simulate fixing a space shuttle, fixing the ISS, or working with other modules. It's the same as far as every rail, as far as every bolt, as far as where every rail should be in place. They have to go turn a bolt 98 times, space. And which ISS module is in the pool right now? Pretty much everything that we have in the pool except for the Russian segment.
They went from a no-pressure environment to a pressure environment, which makes no sense and simulates zero gravity only and exclusively for the camera. First up, Venus, which looks like
it all started with the Big Bang. Contrary to popular belief, not to mention a certain sitcom theme tune, it's extremely unlikely that the Big Bang was the true start of everything. Our universe? Almost certainly, but that's not the whole story. To make things clear, the Big Bang Theory specifically describes the expansion of the universe from a singularity of infinite density about 13 billion years ago. Thanks to the existence of cosmic radiation, which is leftover heat from the Big Bang, we can be fairly sure that it did indeed happen. But the problem is that the theory says nothing of the actual point at which time began, simply that at some point the order of the universe drastically changed. And here's where it gets tricky. Scientists are pretty sure that something came before, but the existing framework of quantum physics doesn't allow for it, and they have no idea what it would even be. Boatloads of theories have been put forward, like another older universe collapsing to form the singularity behind our Big Bang, or that it's an event that happens cyclically in trillion-year cycles. But at this point, they're just shots in the dark, and they all contradict Einstein's theory of general relativity, which isn't a great place to start from.
You can see a little bit of bubbles start going, and whoa, start boiling. How cool is that?
Effervescent antacid tablet in a water sphere. Here's a sphere of water 50 millimeters in diameter with an effervescent antacid tablet. Bubbles form rapidly from a chemical reaction. This is an example of heterogeneous nucleation where bubbles form on a solid surface and can get a momentum exchange and travel out into the fluid. The bubbles rapidly coalesce. Once they reach a certain size, they seem to eat other bubbles at a faster rate, thus growing larger. And in this form of a bubble war, you end up with a bipolar situation with two large bubbles that rapidly eat all the other bubbles. And eventually you get a situation where one bubble dominates and all the other bubbles are pressed into an annular
Interstellar
space.
travel. Now this one's a real heartbreaker. Try as we might, there's a very strong chance that we'll never be able to make it out of our solar system, let alone to another star. But it's not because it's physically or mathematically impossible. For once, the laws of nature aren't getting in the way of our sci-fi dreams. It's for the very sober reason that Earth doesn't yield anywhere near the fuel resources needed to travel those sorts of distances. Using a projected model of global energy production, NASA scientist Mark Millis found that Earth would likely not be able to drum up the 20 quadrillion joules of fuel needed to reach Alpha Centauri until 2200. And that's just for a non-propellant mission. For one that was travelling at any kind of pace, it would take until the year 2500 to produce the necessary 5 quintillion joules. This is all theoretical, but to put it into some kind of context, another scientist predicted that it would take as much as 100 times the world's current fuel output for the mission to reach its goal. And that's not to mention speed. Without an incredible leap in propulsion technology like using antimatter, it would take 50,000 years to actually get there using conventional rockets. Better find a good book or maybe a freezer for the trip.
Water droplets in a bubble in a sphere. Here we have a sphere of water 75 millimeters in diameter with an air bubble inside about 35 millimeters in diameter, and we inject water droplets anywhere from 1 to 8 millimeters in diameter into the bubble and look at the resulting collision dynamics where they collide with each other and the walls. Most of the collisions result in an elastic collision, but every once in a while a collision will result in a mass transfer across the interface, and this mass transfer has a momentum exchange associated with it which will propel the droplets. Here a droplet is going in circular motion on the inside of the sphere until a mass transfer occurs and propels it off the surface. Waves in a large free sphere of water. Here we have a large free sphere of water about the size of my head, 130 millimeters in diameter, and we put a puff of air, 10 cc's in 100 milliseconds, radially directed in from the side, and look at the resulting waves. And there's a combination of surface waves and body waves that go through this sphere. We saw that in real time. Now we see it in slow motion. Starts off with a crater sending a droplet off, and then a series of surface waves which come together at the antipoidal or 180-degree point from the impact, and these waves collapse back down and go across the other side towards the impact point, and they continue until viscous forces dampen things down. A delightful interplay of both surface and body waves here.
Рождеству я посылаю поздравления на станцию, и на ум мне приходят слова французского поэта «Земля голубая, как апельсин».
That happen in the lower left limb of the moon. So watch the lower left there, and I'm just going to run a straight slowed down view, 30%. If you've got sharp eyes, you'll see what we detected on a 60-inch monitor. Now look inside the circle. There's a pulse that goes from lower left to upper right, and in the next circle, the yellow one, there's a lateral sweep that goes from left to right straight across the screen. And this is all going on as the wave is starting at the bottom. So now look at the pulses backwards and forwards. That's backwards. This is forwards coming from the lower left limb of the moon. You can see the pulses now that I've put filters on them, how they have a curved aspect to them. And if you've got sharp eyes, you'll see the sweep up above. Now what I'm going to show you now, we have talked about, and many sharp-eyed viewers have known that this was an important thing about this clip for a long time. Here comes the wave. Look at the dark underlined crater in the center of your screen. Watch how it's displaced, almost like you're looking through water. There goes the wave backwards, forwards, the wave hits the crater, displaces. This wave is displacing, as if you were looking through water, the entire image of the moon. Now I've never taken the time to animate this. I have talked about it. There it is zoomed in. Now this is running at 30%. And I'm going to zoom out. There goes the wave to the top, and there's going to be another wave coming in from the bottom. Now I'm going to run this at 30%, so as the wave comes in, you can choose any landmark you want. Here comes the wave from the bottom to the top. Choose any little landmark you can see there and watch it be displaced. Now that round looking ring crater, forwards, backwards, and one more time forward, and I'll zoom out. And you can watch it go all the way to the top. Again, this is at 30% with quite a few filters like find edge and some other things, invert.
And again, this is a hollow shell of liquid with all the tiny bubbles forming in the shell. Now the rhetorical question comes about how can you remove all these bubbles and get back to a sphere of liquid again? And so here we're sticking in a syringe and sucking out the air. And as this happens, the whole system shrinks in volume. And you keep withdrawing the air until you can see that liquid is starting to be withdrawn from the syringe, and then you've gotten the big air pocket side. And now we're left with a sphere filled with all these little tiny bubbles. And what you can do now is you can start to stir it here with this Teflon cannula, and you can get the rotation motion started. And as we've seen in previous Saturday morning science demonstrations, a rotating motion causes the bubbles to go to the center in this tornado-looking core. And then you can stick in another cannula, and you can remove the bubble core. I'm hoping that we worked with in the TCS system with the new water pump cooling loop and the air bubble that's in there. I hope they're watching this, because we might be able to get some ideas for getting that bubble out. And here, the last little collection of fine bubbles in the core are being removed. And here's a demonstration of what happens of wicking action with a towel. This is one of our standard towels that we use on station, and you can see how once it touches the sphere of water, the capillary wetting withdraws the water into the towel in this rather thick film. And we're right back to where we started now with just a thin film on a wire loop.
Vacuum just becomes a myth and not a scientific fact. Because the simple basic physics of a vacuum in space just doesn't work. If there are any scientists that actually just think about this, or physicists, the whole thing of vacuum in space is just not compatible with any kind of physics formula or physics that we can put to it. Where does the vacuum begin? Vacuum is one of the most powerful forces of nature. Where does that vacuum begin? We often get confused between gravity-free and vacuum. They're not the same thing. Just because there's no gravity doesn't mean you're in a vacuum. And just because you're in a vacuum doesn't mean there's no gravity. The two are not the same thing. So don't get confused by vacuum and gravity-free. What you can't do in space or in a vacuum, what you can't do in infinite vacuum is you can't propel sound. You can't have explosions, fire, propulsion, jet engines, rockets, none of this stuff. Can't do that because there's nothing to propel against. And then these guys on YouTube that make these vacuum tubes, they go, oh, look, I created a vacuum tube in my garage. I'll show you that you can propel a rocket in a vacuum. I go, really? You've lost your brain. You're comparing a fishbowl in your garage to the infinite vacuum of space? You really lost your mind, dude. And then you start watching like SpaceX sending a rocket up into space, and they're very well-trained presenter that's got all the buzzwords. She knows all the lingo and all the buzzwords. And at one stage I was watching and she says, and the rocket is about to enter the vacuum of space. Really? And millions of people are watching this and they believe this. You see, they just, oh, the rocket just entered the vacuum of space. Where? How did it, where? Please frickin' explain that to me. In scientific terms, not in BS terms. Oh, you won't understand it. No, please try me. I want to understand this. Explain to me where that vacuum begins. And we start realizing that everything we've been told about the moon, moon landing, space, is probably one of those big hoaxes. It is a tough one to swallow, but we're going to have to start swallowing it sooner than later. The longer they string us along, the longer the worse this is going to get. So, for those of you that still believe that we landed on the moon, I'm going to shatter that for you right now. If you've not seen Jay Widener's Kubrick Odyssey, that's the first point of departure. Watch Jay Widener's Kubrick Odyssey, and you will never believe another word NASA tells you. You'll never ever believe that we landed on the moon, and you'll understand Stanley Kubrick's role in this entire thing. and why he eventually died when he pushed it a bit too far with eyes wide shut. But basically, everything you've ever seen from the moon, all the images or footage of the astronauts was shot by Stanley Kubrick in the early days. I'm not sure who shot the more latter part, possibly him as well. But the earliest moon landings and all that shot by Stanley Kubrick with his very, very specific style of cinematography. It's a dead giveaway. And that gave him basically the freedom to make whatever movies he wanted. He then made a movie called The Shining to tell us that he was the guy that shot the moon landings. And for some people that still think the moon is a real physical thing in the sky, that we landed on this physical object in the sky, the image of the moon that we see from Earth is part of the agenda. It's part of the particle physics agenda that I'm coming to make us believe of particles that make up everything in creation. And we need to reconsider what the moon is, because after you've seen the lunar wave, you'll never think of the moon the same way again. And this is what the lunar wave is.
Clock. It's not our calendars and our digital clocks keeping track of time. All of our calendar systems and clock systems are based off of the rotations of the cycles of the luminaries and the sun and the stars, and it has to do with the eras and centuries and ages, you know, like the age of Pisces and the age of Aquarius. All that stuff has to do with the star systems. So the stars aren't suns in outer space at various distances. No, the stars are part of this dome firmament, and the stars are here for our signs, and the sky is a clock. The cycles of the moon, that's how we keep track of the calendar systems and the month. If we're traveling through space, we're not going to have the same skies. We can't have that precision when it comes to keeping track of time, because we'd be all over the place. They said we're zigzagging through space at all these insane speeds. We're not going to have the same star systems that people have been keeping track of since recording of time. They should be scrambling all over the place. Why is everything so perfect? And the calendar system, all that stuff is too perfect for life to be some accident. Like scientists try to tell you life is some big bang accident of some singularity appearing out of nothing, blowing up and turning into rocks, and then the rocks turn into lizards, and the lizards turn into monkeys, and the monkeys turn into people, and all the stars in the heavens keep perfect track of time. Our watches are set to the clocks of the heavens. That's what time is. Time is not the calendar on your wall. Time is the cycles of the heavens. The sky above you is perfection. It doesn't deviate. It keeps constant track of time for us to use. Look at the sundials. You can pull out a sundial from way back in the ages and it'll keep perfect time. The sun is running the same routes, just like a bus goes the same route every day. Well, the sun does the same route throughout the year, and that's why the sundial is perfect. It's because the heavens are perfect. It's not a random accident. So you got this display right here. As you can see, the sun travels east to west. So you got the same type of situation as the globe, where it can be daytime in China and nighttime in the US, because the sun goes around the circle plane like a dish plate. So the sun just hovers above and goes in a circular motion, and you still get the same type of time zones and everything. And as far as seasons is concerned, well, the sun doesn't just go in the same path. It takes different paths. It works its way to the North Pole circle, and it goes around that. And then for the winter, it works its way to the Antarctic region and circles around that area. So that's your seasons right there. And with the Antarctica trip around the circle, the sun is farthest away from America, so we get the colder temperatures. And then when it works its way to the northern area, you get the hotter summers because it's closer to you. And then the sun is not as big as they tell you it is. It's much closer. Actually, they say the sun and the moon are the same size, and that would explain the eclipse. It's definitely not that far from us. And you can tell too by sometimes you'll notice the sunbeams shining down through the clouds, it suggests a sun that's not too far. If the sun can focus its sunbeams through a specific set of clouds in the area where the sun is, when you look up, you see the sun, and then the beams are coming down through the clouds. It's as if the sun is right there, a very bright light shining down in that focused area, because the radius of the sunbeams is in a straight relation to where the sun is. So it's all in perspective. So we gotta admit this looks as if the sun is above the clouds. The sun's contained within this dome firmament. Check out my heliocentric deception playlist for much more information on the subject. I'll leave the link in the comment section and the description box.
Sound in space. It's definitely true that in space no one can hear you scream, so don't go trying to correct Ridley Scott on that one. But what's not true is that it's because there's no sound out there. There is, it's just impossible for us to hear. And that's where our good friend science comes in. As I'm sure you remember your grade school science teacher telling you, sound travels in waves through vibrations in particles. The denser the material, the better it travels. So it makes sense that sound wouldn't travel in the vacuum of space. But here's the problem, space isn't completely vacuous. Thanks to the tiny particles of dust and gas that scatter throughout the cosmos, there are places where the makeup of space is dense enough to carry sound, but the frequency is far too low to be perceptible. To put this into context, the lowest sound the human ear can perceive is at 20 Hz, or 20 oscillations per second. But don't even think that it's close to the lowest tone, which comes from the Perseus black hole droning at approximately 20 trillionths of a hertz, or once every 10 million years. And just in case you were wondering, it's in B flat.
You're missing something or misremembering a story. Has anyone ever made you question your reality? Have you ever been gaslighted? This is another field guide to bad behavior. Let's explore how to navigate the wilderness of human nature. Gaslighting is a form of emotional abuse and thought manipulation, with the aim of planting doubts in the mind of a person or group of people to make them question their own memory and perception of reality. It's been spotted in abusive relationships where it can destabilize the victim, make them unable to think clearly and so become dependent on the abuser. It also lives in the social domain and the political arena, where it's used as a tactic to preserve inequality or gain political dominance over large groups of people. Gaslighting may first appear as an honest, logical disagreement, but you can identify it by its telling signs, such as repeated lying, persistent denial of facts and evidence, misdirection, and contradiction. The term comes from a 1938 play called Gaslight and its movie adaptations, in which a husband misplaces objects and blames it on the wife in order to convince her she's losing her mind and should be institutionalized. He also tells her the occasional dimming of gas lights in the house is just a figment of her imagination. In reality, the gas lights flicker because he's turned on the lights in the attic, secretly searching for valuables. Gaslighting as a behaviour was first noted in a clinical report in 1969, which included a handful of cases where people were sent to a mental hospital through an elaborate plot designed to make them look mentally ill. This pure form of gaslighting, in which the manipulator intentionally plots to make someone look insane and get rid of them, is quite rare. More often, gaslighting involves a desire to gain influence over someone and keep them around or keep them from causing trouble. In relationships, gaslighters may repeatedly deny any wrongdoing, even in the face of solid evidence. In the workplace, an employee who's left out of meetings might be told they're just paranoid, and someone who's experienced harassment may hear they're just too sensitive. The idea is to ignore facts, erode a person's judgment, and coerce them into believing an alternate narrative. And this strategy works magic in politics. Although circumventing facts and pushing agendas to masses of people is nothing new, gaslighting saw a spike in interest during the 2016 presidential election in the US, and the term gained a new mainstream recognition. Gaslighting hasn't been studied extensively, and we don't fully understand what drives this behaviour. But we can take a look at its components: compulsive lying and intolerance for opposition. The ability to lie and manipulate others is a universal human trait that emerges early on in childhood. Researchers speculate that it may have given us an advantage by replacing the need to use physical force to get what we want. But most people have limits. Gaslighters, though, lie compulsively and only make up even bigger lies when confronted. And according to philosopher Kate Abramson of Indiana University, gaslighters can't tolerate any challenge to the way they see things. The anxiety about the possibility of disagreement leads gaslighters to erode the other person's sense of judgment and independent perspective.
So, how can you turn off the gas?
Stopping gaslighting isn't easy, but you can start by taking these steps. Pay careful attention to your own experience. Instead of doubting yourself, ask the opinion of a third person and check in with them regularly. When stuck in a problematic relationship, seek help from a therapist. And note that not everyone gaslights intentionally. Be aware of your own behaviours, as well as those of others.
Human relationships can be strange and treacherous, but if you know what red flags to look for, you can try to avoid falling into some traps. Until next time.
3. We know what space looks like. You may have seen photos of formations in space like the Pillars of Creation or the Red Spider or Crab Nebulas, which are some of the great wonders of the cosmos. Well, I hate to break it to you, but supermodels would blush at the amount of photoshopping going on. That's because for all the wonders of the Hubble telescope, it can't capture colour. So in order to produce the awe-inspiring images that we're used to seeing, it takes separate monochrome images through as many as 40 different filters, some of which don't even capture visible light. And Earthbound scientists assemble them manually. That leads to shots in what NASA imaging specialist Jim Bell calls approximate true colour, as the people compositing the images have to make some amount of artistic license based on the data. Just to be clear, no one is trying to misrepresent what space looks like, except on the occasions where it helps scientists when analysing. For example, with the surface of Mars. Other than that, NASA is trying to best represent space according to the information available. So before you go accusing them of cover-ups, you might want to look...
Okay, I'm on the top step. It's a very simple matter to hop down from one step to the next.
You've got 3 more steps and then a long one.
Okay, I'm going to leave that 1 foot up there and both hands down about the 4th.
Engulf everything. Black holes suck, right? Because if sci-fi is to be believed, black holes are funnels of ceaseless hunger that will consume all life, the universe, and everything. Well, sorry, but that's a myth. While it is true that if anything passes the event horizon of a black hole, it will never be able to escape, even to a black hole, the rules of gravity still apply. Gravitational fields are determined by mass, so there is a strict relationship between the matter in a black hole and its pull, just like suns, planets, or any other possible object. And while they do have a far greater mass than anything else the same size on account of their incredible density, the mass is not infinite, so there are limits to their attraction. To contextualize that, if you had a black hole 3 times the mass of our sun, the event horizon would be just a few kilometers. And if our sun was replaced with a black hole of equal mass, the solar system would remain intact and behave in pretty much the same way. It would
You ought to be in pictures.
Not the best?
Let's say it's another one to print. I think that's awfully good. That one and the one before it was pretty good. This
Do we
is
have
really...
about 15 seconds?
Oh yeah, you got a lot of time here.
I claim this land in the name of...
What do you got now? Now move.
I didn't kick it. Cut it.
Ready, and action.
Let's settle, let everything settle. Ready, and action.
Cut it, Jim. Very good.
Print that. Print 4.
He needs to go
41.
off this mark.
Once more, please.
Otherwise, he,
let me walk it for you. Tell me if I don't want
right in the middle of it. You know.
41. So here's what we really need is for him to go to his left and then kind of veer back. Is that right?
The sun. You know how the sky isn't really blue? Well, the same is true of the colour of the sun. While it looks like daylight is coming from that big yellow ball in the sky, our star is actually white, maybe with a very slight peach tint. It's all to do with the comparative heat of the sun. On the Kelvin scale, which is a true measure of temperature from absolute zero upwards, any star below 5000 Kelvin will appear red and anything over 7000 will appear blue. It just so happens that our sun sits at 5780 Kelvin. Not only is that the sweet spot between the Earth being an icy wasteland and a nightmarish hellscape, it also means it shines white, just dipping into a tint of red, hence the peach. So, how come it looks yellow to us? Well, like the sky, it comes down to our atmosphere. The green, blue and violet shades of the sun's light have a shorter wavelength and scatter through the atmosphere. The effect intensifies as the sun goes down or the air becomes more polluted, which is why it can sometimes even look a tiny bit blue at high noon. You probably shouldn't check that one out yourself though, not if you enjoy having eyes that work.
Exactly right, and it has to be, we have to be high enough so that we've got you against blue sky and not against Earth as you're coming in. You're coming in a descending approach as you get in.
Over. We can rehearse it. Said go back and we'll rehearse it and see how it looks.
Okay.
Action.
Head swing.
Quiet.
In the lifetime of mankind was nearing its crucial moment.
Oh, Apollo 11, Houston, we're wondering if you started into the limb yet, over. Okay, Charlie, we're in the limb. The docking index mark is the same. Roger, we copy. Houston, Apollo 11 Eagle, over.
The lunar module Eagle was again given a thorough checkout to ensure the functioning of all systems, as Armstrong and Aldrin prepared to seal themselves off from Collins in the command module and for the two craft to pull apart.
2, 3, 4, 5, 5, 4, 3, 2, 1. Houston out, over.
Okay, it's go there, Capcom on the hot fire. Okay, all flight controllers going around the horn, gonna go for undocking.
Okay, retro, go. Fido, go. Guide, go. Control, go. Telcom, go. GNC, go. Econ, go. Surgeon, go.
Capcom, we're go for undocking.
Hello, Eagle, Houston, we're standing by, over. Houston, we see you on the steerable, over. Roger, Eagle, touch on. Roger, how does it look? Roger.
The Eagle has wings. On its own now, but with Columbia near at hand, it coasted around to the backside of the moon, and there, while out of direct communication with the Earth, it fired its engine to slow its descent to a touchdown on the near side of the moon. Collins and Columbia continued in orbit, awaiting their return.
Okay, all flight controllers, gonna go for landing. Retro, go. Fido, go. Guide, go. Control, go. Telcom, go. GNC, go. Econ, go. Surgeon, go. Capcom, we're go for landing. Altitude 4200. You're go for landing, over. Roger, understand. Go for landing. 3,000 feet.
はもちろんテレビを見られるホテルのロビーとか休憩室に集まっています。私たちは待っているところで。
L'homme pour la première fois prenne pied sur la Lune. Les rues sont loin d'être vides naturellement, mais naturellement aussi c'est surtout dans les halls d'hôtels, les bars et les appartements que les gens se groupent, c'est-à-dire partout où ils peuvent trouver un récepteur de télévision. Et nous attendons tous.
Während die Welt darauf wartet, dass ein Mensch zum ersten Mal den Mond betritt. And the world waited. July 20th, 1969. It is said that 500 million people gathered at TV sets around the world to wait for the first Earthling to set foot on the moon. Countless millions more listened on the radio to the voices from the moon.
This Neil, radio check. Neil, this is Houston, loud and clear. Break.
Never before had so many people been attuned to one event at one time. The world waited, curious, wondering, aware, like a sleeper wakened in the night by a faraway sound. A moment sensed, more than understood.
Surface about 1 or 2 inches, although the surface appears very, very fine-grained as you get close to it. It's almost like a powder. Very fine. I'm going to step off the limb now. It's one small step for man, one giant leap for mankind. That's one small step for man, one giant leap for down 86, minus 00759.
Apollo went into orbit around the moon. The journey that had taken the lifetime of mankind was nearing its crucial moment.
Oh, Apollo 11, Houston, we're wondering if you started into the limb yet.
again given a thorough checkout to ensure the functioning of all systems, as Armstrong and Aldrin prepared to seal themselves off from Collins in the command module and for the two craft to pull apart.
2, 3, 4, 5, 4, 3, 2, 1. Keep it out, over.
Okay, it's go there, Capcom on the hot fire. Okay, all flight controllers going around the horn. Gonna go for undocking.
Okay, retro, go. Fido, go. Guide, go. Control, go. Telcom, go. GNC, go. Ecom, go. Surgeon, go.
Capcom, we're go for undocking.
Eagle, Houston, we see you on the steerable, over. Roger, Eagle, I'm done. Roger, high alert. See
On its own now, but with Columbia near at hand, it coasted around to the backside of the moon. There, while out of direct communication with the Earth, its near side of the moon. Collins and Columbia continued in orbit, awaiting their return.
Okay, all flight controllers, gonna go for landing. Retro, go. Fido, go. Guidance, go. Control, go. Telcom, go. GNC, go. Ecom, go. Surgeon, go. Capcom, we're go for landing.
Altitude 4200. Houston, you're a go for landing, over. Roger, understand. Go for landing. 3,000 feet. You're looking great.
How you doing, Control? We look good here, fine. How about you, Telcom? Go. Guidance, you happy? Go. Fido, go.
2,000 feet. 2,000 feet. Into the ag. 47 degrees. Roger. 37 degrees.
Still looking very good.
Your go. Copy. Alarm. 1201. 1201. Roger, 1201 alarm.
1201 alarm. Same time, we're go, flight. Okay, we're go.
We're go. Same tide. We're go.
Altitude 1600.
Eagle looking great. Roger, 1202. We copy it. 35 degrees. 750. Coming down to 23. 540 feet and a 15. 1050 feet down at 4. Altitude, velocity, light. 3.5 down. 220 feet. 11 forward, coming down nicely. 200 feet. 4.5 down. 5.5 down. 100 feet. 3.5 down. 9 forward. Okay, 75 feet. Guys looking good. Down a half. 6 forward. 60 seconds. Lights on. Forward. Forward. 40 feet down, 2.5. Picking up some dust. Big shadow. 4 forward, drift into the right a little. 30 seconds forward. Contact light. Okay, engine stop. We copy you down, Eagle.